going to start by going over some of the stuff that we have looked at the past 2 sessions. You know, the best way to learn is kind of repetition and getting stuff stuck in your head. So we're going to start out by doing a pop quiz. And I'm going to ask, most everybody has been here for, at least one or both of the sessions, except our new fellow, Jim. So I'm going to make this easy at first, hopefully. And I need somebody to tell me about those type of microphones. So there's 2 types of mics that we usually deal with that we went over. So I need to know what type of microphone it is and what kind of pattern the microphone is.
Condenser mic.
Wrong.
I meant cardioid. Boundary.
Right. Close. All right, so there's 2 types of mics that we usually use, dynamic and condenser. If it's not condenser, it would be a dynamic. So, what kind of polar pickup pattern do you think that this would have?
I think Mike was right, cardioid.
Yes, it is cardioid. Good job. Now, what is cardioid?
It's based on a heart shape. That's where the word comes from, the original Latin. And
Look at this guy.
Nice.
Oh. Spelling bee's coming up here. It's mostly picking up in the front and a little bit of the back and side.
Correct.
Use it in a sentence?
Yeah, I just did.
It's also called unidirectional because it only picks up basically in one direction. So, what's that make of that?
Condenser.
A condenser mic. What's different about this mic than that mic? Does this need anything special?
48-volt fan and power.
Right. Do you know what kind of pickup pattern that is? If you could look at the.
It's
Like a ball, right?
This isn't omni. This is
cardioid?
cardioid. Yeah. So it actually has the same what he was describing, kind of like a heart-like pattern. Although it looks like a heart when it's upside down. What about this guy?
It's also a condenser mic.
Yep. What do we call that one?
I forget the technical term, but we usually call it shotgun.
Shaka mic, a gradient mic. Yeah.
Gradient.
So what application would we use something like this in? Eccles.
Like film.
Actually, yeah, this is probably one of the most used mics for film. We don't do film, so we wouldn't use it for film. Have you ever seen these on our jobs? Yeah, to shoot long distance. Yeah. So this pickup pattern shoots farther distance than than say the cardioid mic. All right, we got one more. Mike, what's the name of this one?
That's a boundary mic.
That's a boundary mic.
Omnidirectional. No.
This is omnidirectional, yeah. So that picks up, all around. Is this a dynamic mic or a condenser mic?
Condenser.
Good job. Jim, do you know the difference between...
I was going to ask you, what's the difference?
Okay, so dynamic mics are passive, so they don't require any power to basically power them and send signal through. So these 3 mics are all condenser mics and need 48 volts to activate them, basically.
That's the only difference. One requires voltage, one doesn't? For the most part?
For the most part, yeah. For our general purposes. All right. Good job. All right, so many
Right, the
slides.
difference is dynamic ones usually have a larger head to pick things up. So you can see the condenser mics are all really small.
Condenser mics are much more sensitive than a dynamic mic, yeah. So you don't need as much gain to get the same level out of them.
They have like an amplifier in them? Hence the power?
Not really an amplifier. But say this guy was hanging from the ceiling. With the same gain level that you would have driving this and that, you'd have to get up like here to get the same volume to where if this was on the ceiling, as I'm talking right now, sitting, 6 or 8 feet away from it.
So, yeah, they're much more responsive. The
Yeah.
condenser mic transient response is much quicker than dynamic. So the fan of power actually charges the element in the microphone.
Exactly. So, our first session we looked at balanced versus unbalanced audio. This week I had a service call to which we were having a bunch of noise and radio stations coming through these speakers. So what was funny about the service call is we walked in, we didn't hear anything because there was no power on the system. And Jim and I, we turned only the amps on. So we left the mixer off, we left everything else off. And just with the amps, powering the speakers, all of a sudden now we're getting crazy radio stations through the sound system. So I looked at how it was wired, which we're going to get into this in a few minutes. But they had a few of these amps, the Crown XLS amps, and you can daisy chain these guys together. So sometimes, what do I do with that cable? Oh, here it is. Sometimes what people have done to daisy chain them together is use unbalanced cables, and these guys have a link out, and then they have unbalanced inputs, on the next one. So without the balanced connection on this,
Does everybody know what makes that unbalanced?
I think we kind of went over that, but so this would be a TS cable, and then you've got TRS, and then TRRS we don't really use, but that would be kind of like if you look at your phone, which has an additional microphone, like your headphone jack, that'll have 3 instead of 2. But we looked at unbalanced and balanced and how the sine waves were different and they were opposite and they would cancel each other out. So basically you could see on the unbalanced system, on the balanced line, you've got opposite sine waves. So basically on an unbalanced line, you've got just one hot feed and then your ground, and that's where you can get noise. But when you have a balance, you have the positive and negative. So they kind of equal each other out, and on a line, it sends the opposite feed down the line, and then it unites at the actual connector to get rid of the noise. So anyway, by swapping this out and literally just installing a balanced XLR connection, we were able to clean that up and get rid of that basically right away. So, all right. So just a recap. The mics we use are dynamic and condenser. There's a few large diaphragm, small diaphragm condensers we use. They require 48 volts to power them. And this is all stuff we went over, so we should know this by now. So cardioid's unidirectional, has a pickup pattern of 131 degrees. Omni picks up 360 degrees, like the boundary mics. Then the gradient or the shotgun mics have what's called the interference tube, and that's their pickup pattern. They shoot a long distance and reject a lot on the sides of the microphone. Just a recap, those are the polar patterns, just so you kind of see what they look like. And last time we talked about the DBX drive rack that we use basically on most audio systems, which is a signal processor. We looked at the ins and outs of them, how they do graphic EQ, parametric EQ, compression, limiter, anti-feedback suppression, all that. They have delays in them too, so our rooms aren't big enough to really get into that, but if you're in, say you're at an outdoor festival, and you've got one speaker, you've got your main front speakers, and then, in front of them, 100 yards into the crowd, you've got another pair of speakers. So you can actually set delays to time it. That way the one is delayed rather than the other one. So, you're not hearing something, 10 seconds, after the fact that it's happening, coming out of the one speaker. So today we're going to look at a little difference between 70 volt and 8 ohm systems. I'm going to ask everybody lots of questions today, and I'm hoping people have lots of answers. So, all right. So out of our 3 amps that we're looking at, we've got a TOA A712, we've got a Crown CDI 1000, and we have an XLS 1002. Which of these 3 amps is a 70 volt amp?
So at A712.
Anything else?
The Crown is also, right? Does it have the option to go?
Which one?
Does the Crown have the option to go 8 ohm and
The CDI? Yeah. What about this guy?
that's just 8
Right
ohm?
on.
Yeah. Yep. So yeah, no, I want all of us to get familiar with the products we use because basically everything on this table we use every month. We have for years and aren't really looking to get rid of any of this. So it's important for us to kind of know about our gear, about what we use, on a weekly and daily basis. So I want to talk about 70 volt audio, which your paper gets into. You can read that later, just a little bit. So how the 70 volt line get its name? So this is kind of a little history about it. The intention was to have a 100 volt peak on the line, which if you meter it out ends up to be 70.7. So 70 volt became the common term. So there's 70 volts on the lines as maximum amplifier output with a sine wave signal. The actual voltage depends on the power amplifier wattage rating and the step-up ratio of the transformer. The audio program voltage in a 70 volt system might not even actually reach the full 70 volts. Conversely, peaks in the audio program might exceed 70 volts. Other high voltage systems might run at other voltages.